Good morning and welcome to my channel. And it's just a continuation of the previous video, whereby in the previous video we were looking at the basic calculations of DC machines and to be specific, generators. And we looked at various examples. And today we shall have like another three examples to emphasize on the same so that we may get better understanding of this topic. So by the end of the video, you should be able to calculate the generated EMF in armature winding, whether connected in lap wound or wave wound. Remember in the previous video we said when the armature winding is connected in lap wound, C is equals to 2P. Point to note. And when the armature winding is connected in a wave wound, C is equals to 2. Are we together? And the general formula for calculating EMF is given by 2P N phi Z divided by C. Welcome and may God bless you as we go together in this. Remember, you can also pause the video as I teach and try to look at the examples one by one and see whether the answer that you will get after the examples or after the exercise are equal or the same as mine. So let's look at example number 4. The question says a 4-pole armature of a DC machine has 1,000 conductors and flux per pole of 20 milliwebers. Determine the EMF generated when running at 600 revolutions per minute when the armature is wave wound, and part B when the armature is lap wound. It's just like what I had said before. So we have, let's look at the solution. N is equals to 600 revolutions per minute. Then this tells us that we have to convert into seconds, so we shall divide by 60. And flux is equals to 20 milliwebers. Milli means we shall multiply by 10 raised to negative 3. And Z is equals to 1,000 conductors. And because it is a wave wound, C will be equal to 2. And for the number of pairs is also 2 because we have a 4-pole. So we shall divide by 2 to get the number of pairs and we shall have 2 pairs. Therefore, E will be given by 2pn phi z divided by C, and our C is 2. So these 2 and 2 here for number of pairs shall cancel. Are you together? So we shall remain with P, for the 2 for number of, 2 for the number of pairs we shall cancel. So we shall have these 2 and these 2 shall cancel. We shall remain with the number of pairs, which is 2, multiplied by the speed times flux times conductors. Therefore, our formula will be Pn phi z. So, when you replace the values from this, we shall have 2 times 20 raised to 10 negative 3 times 600 divided by 60 times 1,000. When you key in these values into a calculator, we shall have the generated EMF will be equal to 400 volts. Are we together up to that point? Let's look at part B, if that is clear. Part B is a lap wound. Therefore, our C will be equal to 2P. Remember, let this stick into your mind very clearly that when it is a lap wound, C is equals to 2P. When it is a wave wound, C is equals to 2. And EMF generated formula is given by 2P N phi Z divided by C. So our C is 2P. We shall have this 2P and 2P here will cancel. Therefore, EMF generated will be equal to speed times flux times number of conductors. So we shall have 600 divided by 60 to change it to seconds times 20 raised to 10 negative 3 times 1000. When you multiply this, you shall have 200 volts. Remember to pause the video and do the calculation. Let's look at example 5 if that is clear with us. And example 5 asks a separately excited generator develops a no load EMF of 180 volts at an armature speed of 15 revolutions per second and flux per pole of 0.20 Weber. Calculate the generated EMF when the speed increases to 20 revolutions per second and the flux per pole remains unchanged. Part B. The speed remains at 15 revolutions per second and the flux per pole is decreased to 0.125 Weber. And part C says the speed increases to 25 revolutions per second and the flux per pole is decreased to 0.18 Weber. Remember, this is in my class. I like to encourage learner-centered, whereby I give examples and students participate. Then I cross-check their work. So you can take a minute and try to look at that example and check whether you have the right thing, as I will be teaching in the next slide. So one, also I would like to appreciate YouTube because of giving us this platform whereby we can teach at our comfort, and you students, you may also learn at your comfort also. Isn't that a good idea? It is. As long as you have bundles and the device, you can learn at your comfortable place. And learning is flexible because you can learn at your own free time. Okay, let's try to solve that question. Part A of that question is asking us to calculate for the generated EMF if the the speed remains increases to 20 revolutions per second and flux per Weber remain unchanged. And we can see that N1 is equals to 15 revolutions per second, flux 1 is equals to 0.2 Weber, E1 or generated EMF is equals to 180 revolutions, not revolutions, but 180 volts, sorry. So in this case, we are looking for E and E2. En2 is equals to 20 revolutions per second and flux per pole is 0.2 Weber. So in this case, we shall have our formula as E1 divided by E2 will be equals to flux 1 divided times N1 divided by flux 2 over N2. And let me repeat, our formula will be E1 divided by E2 will be equal to flux 1 times speed 1, all of this divided by E2 or flux 2 times N2. Let me now put it in a value so that we may see it clearly. We have said that E1, which is 180, divided by E2 will be equal to 0.2 times 15. All of this divided by 0.2 times 20. Then we make E2 the subject of the formula, whereby we shall multiply by E2 over 180 times, we are making E2 the subject of the formula here. So therefore, we shall multiply by E2 over 180. In the other case, also E2 over 180. Therefore, E2 will be equal to 180 divided by 0.2 times 15 divided by 0.2 times 20. I believe it's clear. So if you perform this in your calculator, we shall get our EMF to be 240 volts. I know you have not understood in that section, but let's look at part B. I know you shall see it more clearly in this section. This is a new example I had not teached. We had not learned it before, but it is very easy. Don't have a mind of as if it's difficult. Question part B says the speed remains 15 revolutions per second and the pole flux is decreased to 0.125 Webers. Speed is decreased to 0.125 Webers. So I can see that I never changed, but let me check in the example whether I changed. Part B, yes, part B is changed, it's here. So E1 remain unchanged, we are looking for E3. Flux per pole in E1 remain unchanged, speed remain unchanged for E1, but for E3, for E3, flux is equals to 0.125 and the speed is 15. Speed here remains unchanged, as the question says. Therefore, when we make the subject of the formula E3, we shall get 180 divided by 0.2 times 15. All of this divided by 0.125 times 15. So for if I were you, I'll first multiply 0.2 times 15, then I multiply 0.125 times 15, then whatever I get here, I divide with this, and whatever I get in this area, I divide with this. I have my calculator here with me, so let me check and let me perform the calculation. 0.2, let's multiply together. 0.2 times 15, that is 3. So if you perform this calculation in this bracket first, we shall have 3. Then let's look at the other side. 0.125 times 15, that is 1.875. So we shall have 180 over 3 and over 1.875. So in this area, we shall say that 3 divided by 1.875. So we shall have 1.6. So E will be equal to 180 divided by 1.6. 180 divided by 1.6. 180 divided by 1.6. We shall have 112.5 volts. 112.5 volts. So I believe it's clear now. Let's look at part C. Part C of the question says the speed increases to 20 revolutions per second, 25 revolutions per second, and the flux per pole is decreased to 0.18 Weber. So we can see here is the solution. N1 is equals to 15 revolutions per second. Phi 1 is equals to 0.2 Weber. And E is equals to 180 volts. We are looking for E4. N4 is equals to, the speed has increased to 25 revolutions per second, and flux per pole has decreased to 0.18, sorry. It's supposed to be 0.18 Weber. Therefore, our formula will be E1 divided by E4 will be equals to phi 1 times N1, all of this divided by phi 4 times N4. When we make E4 the subject of the formula, I think I can say I never changed this. This is supposed to be E4. the subject of the formula, we shall have 180 divided by 0.2 times 15 divided by 0.18 times 25. I have said in the previous section that this, if you want to get it clearly here, you can key in into a calculator, open brackets into a calculator, then say 0.2 times 15, close the bracket, put a division sign, open another bracket, say 0.18 times 25, close the bracket. What are you getting as your answer? Mine is 0.6667. So I'll say 180 divided by answer. And my answer is 270 volts. I believe you have done the same also in your side. And that is the end of that section. And my class doesn't end without an assignment. So I have an assignment for you. And the assignment says a separately excited generator has a no-load EMF of 230 volts at an armature speed of 60 revolutions per second and a flux per pole of 20 Webers. Calculate generated EMF when the speed increases to 20 revolutions per second, 80 revolutions per second, and the flux per pole remains unchanged. Part B, the speed remains 60 revolutions per second and the flux per pole is decreased to 15 Webers. And part C, which is the last part, the speed increases to 90 revolutions per second and the pole flux is increased to 30 Webers. This example is more of the same as our previous example number 5. It's just changing the values. So if you have understood the example 5, it will be very easy for you to perform the assignment. That's all for the video. May God bless you and grant you wisdom that you may learn and understand more in your area of study. Bye. Let's meet in the next video.